When we solve systems of linear equations using matrices, we want to get the augmented matrix that represents our system of equations into reduced row echelon form. And there's 3 row operations that help us to do that. Number 1 is to switch rows. The reason we can do that is switching the order of 2 equations doesn't change your solution any. We can also multiply a row by a non-zero constant. That's equivalent to multiplying both sides of an equation by a non-zero number, and that also doesn't change your solution. And adding a multiple of one row to another row, that's what happens when we've done elimination. For example, on this one, if we multiplied the second equation on both sides by -4 and then added the 2, we would have gotten rid of the x. It's the same thing happening. So let's solve this one. We'll start by writing it in matrix form. We'd like to get rid of the fraction. It'll make the arithmetic easier. So let's multiply row 2 by 2 and replace row 2. Row 1 will stay the same. We need to next get this bottom left entry to be 0. We can do that by multiplying the bottom row by -2 and then adding the first row to it. Fortunately for us, 19 goes into 57 evenly. In fact, let's divide the row 2 by -19. Now the next spot we want to be 0 is right here. So we can get rid of that -3 by multiplying row 2 by 3 and then adding it. So now we have the zeros. Now we make the ones on the diagonal. So we'll need to divide row 1 by 4. So our answer is the set consisting of the ordered pair 7/2 and -3. Let's check it to make sure we didn't mess up somewhere. So it checks. Let's solve this system of equations. First, let's write it as an augmented matrix. Now the first thing we want to do is have these 2 spots be 0. Since we already have a 0 up there, we could switch the first 2 rows. Also, notice that each number in the bottom row is even, so we could divide by 2. So to get this spot 0, we could take 3 times row 1, add it to row 3, and replace row 3. Also, while we're at it, it's nice to have a 1 up in that spot as long as it doesn't result in any fractions. So let's just multiply row 1 by -1. I'm just going to write 3 times row 1 just above it. It's really easy to make arithmetic mistakes. Next we want to zero out that -3. And then if it doesn't result in fractions, make that a 1. However, if we divide by 2, we're going to get a -3/2, so we'll just leave that as a 2. This one is a little trickier because 2 and -3 aren't integer multiples of each other. We can get around that though. The least common multiple of 2 and 3 is 6. So we'll make one of these 6 and one of these -6 and then add. So we'll have 3 times row 2 plus 2 times row 3, and we'll replace row 3. We'd like to have this number be a 1 if it doesn't result in fractions. And 19 goes into 38 twice, so we can do that. We'll take -1/19 times row 3 and replace row 3. Now we want to zero out this spot and this spot. And let's do those simultaneously. We can take 2 times row 3 plus row 1 and replace row 1. And we can take 3 times row 3 plus row 2, replace row 2. Now what's nice about when you take 2 times row 3, these first 2 spots stay 0. They won't undo that 0. That's why it's important to follow a certain order when you're making things 0. We'd like this spot to be a 1, so let's take 1/2 row 2 and replace row 2. As you do the problems, you might be tempted just to erase things instead of rewriting it each time. That's dangerous because if you make a little mistake and don't get the right answer in the end, you have to start all over. It's better to cross things out. In fact, I'll do that for the next step. We want to get rid of that 5, so we'll take -5 times row 2 plus row 1, replace row 1. So I can say, okay, 0 times -5 is still 0, so that'll stay a 1. Here we'll have -5 plus 5. I'll just cross that out as 0. Then I have a record. Okay, 0 plus 0 is still 0. Then we're going to have -5 times 3 is -15 plus 13. That becomes a -2. And we've got a solution. Let's check. And it checks.